And thank you, everybody, for coming here and electing to spend an hour with me. I know I'm the only thing between you and lunch, so I'll try to stay on time here. I've done this presentation in 15 minutes. I've done this presentation in 2.5 hours. I'm going to try to do it in 45 minutes today, so I'm going to make sure to leave some time for questions at the end. So please feel free to jot things down as you come across them. So as Randa said, my name is Justin McKeag. I'm a product manager with MarkLogic, based here in the Bay Area. I've been with MarkLogic for over 10 years now, so I think this is my 11th MarkLogic World. So who out there, anybody out there been to more than 5 MarkLogic Worlds? I think we got a couple in the back there. How many of you, is this your first MarkLogic World? Great. Well, welcome. And we appreciate you being here. So in terms of my duties with MarkLogic, as I said, I'm a product manager. I focus on our data integration roadmap. Thank you. I focus on our data integration roadmap, as well as the things that developers touch. So Query Console, the Node.js API, the Java API, those are the things that I manage. What I want to do today is talk about Agile data management with a multi-model database. So you'll be hearing a lot about data silos this week. I'll talk a little bit about what a data silo is, what we mean when we talk about data silos, and why they're a problem. So you can think of a data silo as parts of an organization's information assets that are managed independently. So usually organized around a specific application. And as Gary said this morning, it's not that we've designed our organizations to have these data silos. These data silos might have come about because of M&A. You acquire a different company, you get their ERP system, you get their CRM system. It might happen because you want autonomy in your lines of business. You want to be able to move fast and break things without affecting the rest of the business. And those are all great reasons. It might just be pragmatism. It might just be that it's going to be it's going to be easier for me to develop my own specific view of that data to suit my particular needs than to have to wait for the rest of the organization. And these are all great reasons, but still that presents a problem. Does this sound familiar to people out there, the situation of having data silos? And the problem is that you don't have a holistic view of the data. So one of your key assets in your organization, you don't understand how it's being developed, it's being shared, it's being used throughout your organization. So this presents not only a problem with knowing your data, but also it presents a governance problem. So the ability to ensure that the policies that you want to adhere to as an organization are happening in each of those independent views of that data. So how have we addressed this in the past? And Gary talked about this morning as well. So this is going to be kind of a reiteration of what we were talking about this morning. So there have been multiple approaches in the past for integrating across these silos of data. One of them, of course, is the data warehouse. And the data warehouse is great if you want to be able to do ad hoc query on predefined dimensions. That is what the data warehouse was designed to do. However, that makes it hard to handle changes. We'll talk a lot about agility today. The data warehouse allows you to do those predefined aggregate reports, but it makes it hard to handle changes. One reaction to having that centralized view in the data warehouse was taking the opposite end of the spectrum and integrating point to point. Again, we saw this morning as well at the keynote. So take that centralized approach and completely decentralize it, and have each of those source systems and target applications do the integration themselves. And of course, that's very flexible, but you can imagine the complexities. You start to get more source systems and more target applications. And then what you're doing is you're entrusting that integration. So how does a customer flow between these two systems? The definition of that, you're entrusting to that particular integration itself. And that's probably going to be different for all those M times N integrations that you have. Again, so you've got a lot of flexibility, but you've got very little control over that, and the whole thing becomes brittle. And the data lake was a response to these two ends of the spectrum. The data lake allows you to load your data without predetermining what it is. But then it's kind of up to the users of the lake to govern and to use it. And that was OK. But I'll argue that in today's environment, there's heightened urgency to be able to get more control over your data, to understand your data, to move with it agilely without giving up on governance. So what are some of those drivers? There's new competition. So every industry has been affected by threats from upstarts. even the largest and most conservative organizations. You'll see I've got a screenshot of Metromile here. That's a startup here in San Francisco. And their thing is that they can harness your driving patterns by collecting new data and building an analysis about it to do dynamic pricing of insurance. That is a completely different model. That is a software-based model that is a threat to the traditional way that car insurance is delivered. And of course, with things like that, we've got more data. Everyone is now a software company. Even if you don't think you're in the software business, you are in the software business. Because of all these new types of data, because of all of the new types of applications that you need to be able to build to address some of these threats, software and data are going to be a huge enabler, and it's going to make and break your ability to compete. And with all this new data and all these new applications, of course, come new ways to abuse that. And the response to that is with regulation. So you're seeing a lot of new regulations. And if you look in things like the banking industry, that was a very early a vanguard of the regulatory environment. You'll see things like Sarbanes-Oxley or Basel III. And these were governing the regulators, ensuring the transparency of how these banks were making decisions. So how are they calculating risk? What was the data that contributed to that risk? And you're seeing that more and more. GDPR was a regulation recently enacted in the EU. And with GDPR, you need to be able to understand how each of your customers' personal data is being managed. You need to be able to access that for your customer. You need to be able to get consent from your customers to share that data. How do you know what a customer is if you've got 500 representations of those customers over 300 different systems? So this is what we're talking about breaking down those silos in order to operate in this new environment. So of course, everyone knows the punchline here. You'll see a lot this week about operational data hubs. And this is the architecture that we are using with MarkLogic's unique differentiated technology in order to solve these data silo problems. So the ability to build these transactional, these operational apps on top of integrated data without having to compromise on governance. And the idea is to get that 360-degree view of your organization and be able to operate agilely. We'll talk a lot about cumulatively managing data, whereas the more data you have, the less cost those those marginal applications are going to be. And we'll talk a lot about this today. So I want to talk about enabling agility. I want to focus on 4 key principles. And again, you'll hear these throughout the week. The first one is about API first. And it's not literally about APIs or being first, but it's a way of thinking. And Gary did a great job about talking about, rather than going left to right, loading the data and figuring out what to do with it, move right to left. So this is about leading with business value. It really is the direct analog to Agile software development. Who out there is doing Agile software development or is aspiring to it? So really, this is going to enable that you to act agilely and support that Agile software development. So expecting and embracing change is doing that judo move to take the invariable changes that are happening upstream or downstream and being able to leverage those as an advantage rather than as a risk. We'll talk about how MarkLogic's technology enables that. Governed by default is about ensuring that all access to your data adheres to the policies of your organization. So previously in the siloed world, the data was governed according to the particular application that it was supporting. That's not sufficient, especially with these overarching regulations. We'll talk a little bit about how MarkLogic's technology enables you to govern your data by default. And finally, in order to be agile, you need to be able to deploy it on a variety of different infrastructures, to align your SLAs with your costs, to expand and contract based on traffic. And we'll talk a little bit about how MarkLogic's technology enables that as well. And I've got this little MLW18 flag up in the upper right-hand corner. I've got a cheat sheet here. So as we come across other sessions throughout the week, I'll try to highlight them as follow-ups. So I'm not going to try to. I'm not going to do much of how today. I'm going to talk about why and different ways to think. These other sessions throughout the week will tell you how to do some of the things that I'll be talking about today. So fittingly, we'll start with API first. So API is an application programming interface. And you could think of it as the friendly face to your data and your business processes. Or if you're a little more lawyerly, you can think of it as the contract to downstream consumers. For example, Salesforce generates nearly 50% of its annual $3 billion revenue based on APIs. So APIs are the glue between systems. If you're doing or thinking about doing microservices, APIs are the way that your services connect to each other. These are the backbones of a modern service-oriented architecture. But what I mean by API first is not just about building these interfaces in order to allow business processes to consume integrated data. It's about rethinking about starting with the downstream benefit. So thinking about how your data is going to be consumed, what business problem it's going to solve, and working backwards from there. So this is really important. This is a really big mind shift. Gary called it a mind shift this morning. I don't generally use shift when I'm talking about it colloquially, but you get the idea. But it's about starting with value. Just like in Agile software development, it's about addressing a problem and doing the minimal amount of work in order to solve that problem. Data integration is really hard. It's really expensive. And you don't want to do extra work. You want to solve the problem at hand, pull in the data only that you need, harmonize only the data you need to solve that problem, and then iterate. So this is about getting those rapid feedback cycles. So if the API is first, what's next? So you'll see similar diagrams like this. So the important thing to understand here is that getting value out of integrated data is not a linear process. It's a continuous cycle. And this is really important. As with Agile software development, it's about iterating and getting feedback at each iteration to make sure you're still focusing on the business value. So in this case, we want to define the API. Defining that API might be saying, as in Joe's example this morning, it might be, I want to price dynamically. I want to take into account my customers, my inventory management system. So I'll have a dynamic pricing API. I want to publish the shape of that API, and maybe the first iteration is just a mock. I will just put some dummy data behind that and allow my customers to understand it, to use it, to kick the tires, to get a feel for it. And that might be your first definition of your API. Next, move on. What is the data that I need to support that API? What are the core aspects of my business that I need to do dynamic pricing in my business? It's probably going to be something like customers, products, inventory. And again, the idea here isn't to design an entire model of the entire scope of your business to declare everything up front. You'll probably get it wrong, and that's okay. Again, this is an iterative process. So identify those key aspects of that. And so let's say we'll start with customers. That's your anchor entity, if you will, that core business that's going to help you define that dynamic pricing API. And let's start with entity. Maybe that's the first thing you model. That's the only thing you model at this stage, is we want customers. Now, the third aspect is say, okay, so we're going to need to have some view of the customers in order to support our dynamic pricing API. Where do I get customers? So this is when you start talking to the upstream DBAs, the guy who owns Oracle apps, who's got the ERD on his wall. But again, you don't want all 16,000 tables in Oracle apps. I think 16,000 tables is what it was up to last time I counted. You don't want 16,000 tables. That's a lot of work to discover and integrate that data. You want to have a conversation with the DBA about, here's the aspect of customer that I'm interested in, because I know exactly what business value I'm going to deliver in my API. So have that discussion and pull that data in. And we'll talk about the flexibility of pulling data of different shapes and sizes and quality into the database to be able to discover it. And then once you've got the data in, you've defined your core entities, you can now do the actual work of data integration. Again, data integration is really hard work. We want to do as little as possible in order to deliver that business value. So now once you've wired it up, you've harmonized it to those customers, you've exposed it in that API, you can now get feedback at the next loop. So instead of having a mock API, let's have our first crack, our minimally viable implementation of dynamic pricing, using the data that was actually pulled in from the ERP system. And then we can get feedback on that. And let's iterate. Maybe it's pulling in new data sources. Maybe it's adding different aspects of the data we brought in. Does that make sense? It is the opposite approach of what traditionally we've seen in data integration. Because it was so expensive in the relational or the warehouse world to assemble that schema that's going to handle all of your sources of data and all of your APIs, there had to be a lot of upfront work. With MarkLogic, you don't need to do that upfront work. It's iterative, and it supports that Agile software development. So how do you pick the API that you should start with. And again, this shouldn't be an exercise to figure out all of the possible use cases for eternity for your organization. That's going to get you into analysis paralysis. What you should do is plot them against level of effort and business value. And so things like dynamic pricing here might be a quick win. It's got good business value, but it's not a lot of effort. Whereas something like predicting fraud might have high impact, but it's going to have also a lot of effort to go into it. And so again, the idea is not find out all of the use cases and design for them. Pick things that will add value. And if it's along that 45-degree line, maybe you pick the quick win that's less effort to get immediate value. The last aspect of APIs in MarkLogic that I want to talk about is the technology that underlies how you deploy APIs. And there'll be a great session today. Eric, can you raise your hand, please? So my friend and colleague, Eric Hennem, will be talking about how you actually implement some of these APIs. And one of the differentiators with MarkLogic is the ability to run code in the database. And this means that you can write the equivalent of stored procedures in a proper scripting language, so XQuery or JavaScript. So this allows you to implement logic next to the database without a lot of expensive conversations. So this is a way to deploy those APIs and then deliver them over HTTP. And we have clients that consume those APIs. And we'll be talking about the next generation of this later today. I think it's at 2 o'clock. Let me look at my cheat sheet here. Yes, at 2 o'clock. So really, this is a really unique to MarkLogic, is the ability to run code to implement logic that you couldn't really describe in things like SQL or PL/SQL, of having ifs and elses and looping. And this is a key way that MarkLogic enables those APIs. So our second key principle is expecting and embracing change. So how many of you have worked on a project where the requirements stayed the exact same from the beginning until the end? I see no hands, and if I did see any hands, I'd call you a liar. Because that's impossible. That's just not the way people work. That's not the way systems work. Things are going to change. And if you can't anticipate those, if you can't handle those changes, things are going to break. So what we want to do is we want to do the judo move and flip that on its head. We want to use that change as a way to get to business value faster. We want to use that as a strength instead of a weakness, instead of a risk. So where are those changes coming from? You could have new data sources. So in our ERP example, you could acquire a new organization. They could have their own ERP system. Now you need to figure out customers and inventory across 2 different systems. You can get new data sources. We have a lot of customers in the intelligence space. And they're picking up people on the battlefield. And they've got a bunch of pocket lint. They've got somebody with 4 birthdays. That is messy, unexpected data that probably would be very difficult to otherwise model. And you can have ambiguous and conflicting definitions. That ambiguity is key in a lot of these applications. How much confidence do I have in this measurement that I got? That the fact that I have 2 measurements and the confidence in them is an important aspect of validating the trustworthiness of any data. Those changes could come from downstream business requirements. So you've got new opportunities that the fact that you're integrating this data reveals. And what you want to do is you want to enable the business to be able to experiment. You want to be able to try new things. If that involves a 9-month project to set up a data warehouse and then do some ETL, that's not going to be very conducive to experimentation. You want to be able to enable new ideas and fail fast if you need to. That's OK. That's about tapping into these new opportunities. And then finally, as we've talked about already, the regulatory environment is changing rapidly. I think it was from a bank that I heard that they have 200 different reinterpretations of regulations every day that they need to accommodate. So what you want to do is you want to not have to disseminate all of that information into the heads of developers throughout your organization. You want to enforce those regulations in the database itself, close to the data. So let's go back to my tried and true price dynamically API. You can see our plug is the universal view of API. So again, we'll start by identifying the API, the shape of the API. So maybe we want to identify the customer, maybe his basket of goods. So we'll start with our anchor customer. And then we determine that we can get that from the ERP system. So this is stuff we've talked about already. And what we want to do is get the data as soon as possible with as little work as possible. And one of the ways we do that in MarkLogic is to convert it to a document. So document is one of the key data models that's supported in MarkLogic. So documents are the main way we represent data in MarkLogic. And there's some benefits here, even with one data set here. The document itself defines its own schema. So you can have many different shapes of documents. We'll talk about how it's beneficial to have a common schema to talk about these. But initially, when we load our ERP data, we just want to do a physical transformation. We want to get all of those 25 tables that represent the aspect of customer we're interested in into a single document. With that single document, it's easy to find. It's very efficient to load that document up. So now what we've done is we've done a physical transformation. So the data is still represented as it is in Oracle, but we've gotten rid of all of those messy joins and all of the work that you have to do to assemble that logical customer from your ERP system. And we've represented that in a single unit in MarkLogic. We can also use that document, the flexibility of that document model, to attach metadata. So what was the process that loaded this document? Where did we get this data from? How did we transform it? And so we've got this ability to store the source data as it is in the semantics of the source system, as well as some metadata about it. And then we can do things like tag it into a collection. So you can think of collections in MarkLogic as many-to-many labels. So a document can be in many collections, or a collection can have many documents. And so literally, this might be our first draft at our API. Very straightforward, very low cost, very experimental. So we want to try ideas out again, remember. Let's talk a little bit more about documents. So since humans have been writing down information, they've been creating documents. Just a document is a natural way to represent data. I mean, even without seeing the details here, you can see the structure of this document. It's got labels, it's got values, it's got different types of data, it's got different cardinalities of data. You can see there's many names, each of which has a social security number and an address. So this is a natural way to represent data to humans. And it's actually a very unnatural thing to break this up and normalize it across tables. I see people up front here nodding. And so these documents are great at representing everything from highly structured data, from a relational database, for example, all the way to free text. So it's that entire spectrum of being able to represent that data. And the document allows you to have a single unit to represent some very complex, sometimes complex hierarchies like this. So built into MarkLogic, we can handle JSON, XML, and even free text. So these are the core data formats of MarkLogic. So let's look at what happens when you load from Oracle, for example, this ERP document. So we can load it as is. You'll hear a lot about loading as is. And loading as is doesn't mean you have to. It doesn't mean there's no ETL, there's no transformation, but it's more of an ELT, where we're loading it in the semantics and the shape that it was represented in the source system. And then once it's loaded into MarkLogic, everything is automatically indexed. This is called the universal index because it indexes everything. It indexes values, full text, structure. So this is a key way that we can not have to pre-declare our documents, yet still be able to query them efficiently. So this is going to be really important as we discover what data we have. Because sometimes the data that we're getting in order to integrate is actually not what we were told it was. There might be quality problems. There might be a bug. There might be the message queue has gone awry and sending us the wrong things. So again, it's important to not have to pre-declare this and be able to discover it as is. And in the case of systems that exist today, not greenfield applications, you probably already have documents. So if you're conveying inventory levels or product orders over your message bus, you're already assembling documents. That's the way a message bus communicates. You're probably putting XML or JSON in your documents in your message bus already. Or if you're assembling Java objects with something like Hibernate, you're assembling hierarchies that represent customers. So you probably already have documents somewhere in your organization. But of course, this isn't really data integration yet. This is the ability to flexibly load data from another system. So given the feedback on our first iteration of our dynamic pricing API, we want to also incorporate some aspects of the customer. For example, his lifetime value from our CRM system, or his order history from our e-commerce system. So this is where things get very interesting and where MarkLogic really shines in terms of integrating data. So of course, these three systems are going to have three different representations of the customer. That's the silo problem. The things that they track are going to be different. The way that they describe those things are going to be different. But again, we don't have to do that integration up front, outside of a managed system. We can load that data as is, side by side, into MarkLogic, and then make sense of it. So once it's loaded as is, without any transformation, we can do things like secure it. We can attach properties on it. We can attach permissions on it so that only the people that are doing the discovery and the modeling can see that raw data. So here we've loaded it as is. It's automatically managed. That's the DBMS aspect of MarkLogic as a database. And then we can ascribe metadata to it. So what happens next? This is the magic, of course. So we want to take those three different aspects of the customer and expose it as this harmonized view, this in the language of the business customer, in order to fulfill our dynamic pricing API. So the first thing we'll do is we'll define the aspects of the customer that we're going to need to implement our API. And the idea here is that these are kind of the core concepts associated with our business and our business processes. So this isn't related to any of the source systems in particular, but it's things like name and address. It's our social security number. It's that lifetime value. So we're going to define those core concepts. And we have a special data type in MarkLogic that allows you to make assertions like this. So customer has a social security number. Those three aspects of that assertion are a triple. And we have a special mechanism to load assertions in threes and index them in order to do efficient graph-style queries. So I can ask for all of the entities that I know about that have a social security number. And we'll talk a little bit about more of that sophistication. And what I can do now is I can use that information about the properties of this canonical customer. Again, we're not trying to model every customer for any use case. We're just trying to fulfill this API first. And I can use those in order to materialize these canonical customers. So, aha, you say, materialization, that's bad, right? In our previous example, we were able to build that canonical customer at runtime with a query. That's incredibly flexible. We could query, because of that universal index, we could query the CRM version of the customer, the ERP version of the customer, and the e-commerce version of the customer, and mix and match that at runtime. But what we really want to do is be able to have a way to attach metadata, and then also to make that a very less labor-intensive process in terms of the CPU. So be able to have that so that we have a canonical customer in the database that we can query over, that we can get very easily. So what that process is called, it's called harmonization. Oops. So taking that canonical view of the customer and then extracting the aspects of it, only the aspects we care about. Again, we're not doing the entire thing right now, and promoting that into this materialized view of that customer. So now we've got our raw data. We've got our canonical materialization of that customer in order to support our API. And just like we described the entity, we can also describe the relationships between these assets with those triples. So we can make assertions that this customer was derived from these three instances. These three instances were generated by this particular ETL process. The versions I'm storing as I track it are revisions of these things. This instance that I've materialized is of type customer. So again, this rich graph of information about your data and your processes. In this case, we also flag the social security property as PII. So now I can do queries like, what are all the PII pieces of data that I know about? What are the entities that are related to PII? So again, these are about semantic relationships. And we have built-in technology that allows you to build these graphs. So think of your entities as documents, so customers, products, orders. Those are naturally hierarchical things. We want to represent the relationships between the entities and other entities as assertions, as these triples. We can also infer relationships. So we can use the engine built into MarkLogic to say a customer that places an order that includes a product, we can infer that there's also a relationship between customer and product. We can also represent the data dictionary. So we can represent the entity and their properties and their relationships. This is a great way, we call this entity services. This is a way of defining what your core business entities look like in order to build that harmonization, in order to publish those APIs. And finally, we could represent relationships between facts. So in this case, we might have our product taxonomy might be represented as SKOS, which is Simple Knowledge Organization System, just a way of representing assertions. So I could have footwear is a broader category of shoes, which is a broader category of sneakers. Sneakers is the same thing as tennis shoe. So those are the type of facts that I can now represent. And you can imagine the types of rich queries that I could use. So anytime that I search for sneakers, I also want to search for things in footwear. So again, having this flexibility to represent your entities as documents and then link them up to this graph of knowledge with these triples. And then have indexes that support them all together in the same database kernel. And what you'll end up is something that looks more like this. So this is probably a teeny tiny sliver of what a real implementation would look like. But you can see this is cumulative. So we've implemented our dynamic pricing API, but next time when we want to flag fraud, we're not starting from scratch. We're not defining a customer in terms of fraud. We're extending our existing customer. Maybe we're even changing it. Again, with Agile, the progress you make you should not be scared of refactoring it in the next several iterations. So again, the flexibility of MarkLogic allows you to handle this type of change. That's the agility that you get out of having this document and semantic model built into the same engine. Whew, how am I doing on time here? Still have 2 sections left. So I'll tear through this pretty quickly because the meat of my presentation was in that. So the whole point of bringing data together is to share it. If you didn't want to share it, then you might as well just keep it in your silos. So the whole point of bringing it together. But why would a line of business want to share their data when they can't be ensured that their policies are adhered to? So what we must do is to have those policies defined and enforced at the database level. And track as things change, again, because inevitably things are going to be changing. So how many people have had a conversation like this? So the domain expert here can express his business rules in the language of the business, and the developer has absolutely no idea what he's talking about. So what we want to be able to do is to capture some of those rules, some of the things that define the business processes, the constraints, and put them as data in the database next to the data that they represent and the source data from which they came. And once you've got those as data, you can now write queries on top of them and drive software. So this is model driven. So be able to ascribe rules in terms of the entities that you've defined in your data hub and make those actionable. So one aspect of that is around confidentiality. So we've worked from the ground up to make MarkLogic the most secure database out there. And one aspect of that is confidentiality. So if you think about back to our customer example, so we've made an assertion that a customer has a social security property. Social security number is a personally identifiable piece of information for Americans. And so the first thing we do is let's just make that assertion. So now this is something that we can look up. This is a rule about our data. But the next thing is we can use that rule to do things like automatically generate a configuration that secures where the social security number is represented in that materialized view of the document. I can audit all the things that I know are social security numbers in my database and ensure that they're being protected. I can do a full text search on the things that I haven't yet flagged as PII, personally identifiable, and identify things that might be social security numbers. Maybe somebody stuck a social security number in the notes tag. Who's done that before? I can use full text search and MarkLogic to identify those things that might be PII and flag them as such. And then automatically, they will participate in that protection. So this is really about putting those policies in the vernacular of the business, storing them as data in the database next to the data, and then making them actionable. And there's a great presentation by my colleagues, Kyle Milani and Charles Greer, that will go into exactly this implementation with PII. So define this customer, its social security number as a property, and designate it as PII, and have that affected automatically in configuration. So really, this is an important aspect of the Data Hub. Again, it's about sharing and then ensuring that nobody can have a view of the data, a piece of the data that doesn't adhere to your policies. There we go. OK, so our fourth and final key principle is deployment anywhere. And MarkLogic was built from the ground up to be flexible in how you can deploy it. And the key idea there is to be able to match your SLAs, how you want to be able to service your APIs, for example, with your infrastructure costs. So that means scaling up and scaling out. That means tiered storage. Put your high-value data on the most expensive infrastructure, your lower-value data that you're not accessing as much on cheaper infrastructure. And we've done this on-prem. We're now working aggressively to move that into the cloud as well. So the first thing, let's illustrate this flexibility by talking about our cluster architecture. So our cluster architecture is a huge enabler for this flexible infrastructure. So what you're looking at here is actually my laptop. So MarkLogic ships a single binary, and that installation on a host. These circles are representing a single machine. This is my laptop in this case. And that's actually also your first cluster. So you've got a single binary that can accommodate queries, that can evaluate queries. That's what Joe was talking about this morning, the E node, as well as that can handle data. That's the D node. So on my laptop, I've got a combined. That's very good for development. And this is the same binary that's going to be running in MarkLogic production, so you can be assured that your queries are going to act the same. And depending on your query and data requirements, you can also split the query and evaluation. And this is what Joe was talking about with query as a service. This is where you can split, and now MarkLogic will manage scaling those E nodes in the cloud. So this is a great way to begin that journey. Can anybody tell me why these data partitions? Why these data partitions are called forests? So in MarkLogic, a forest is an independent slice of the data and its indexes. Nobody? It contains trees, says Mike Bowers up front. Exactly. So remember, our documents are tree structures. And what's a collection of many trees? Well, it's a forest. And there's an intermediate structure called a stand that happens in there. So that's why they're called forests. So just think of them as partitions. So they're an independent slice of data and its indexes that's managed. So in this case, we've got one evaluator node, one data node with one partition of that data. Now, if you wanted to add additional query capacity, add some E-nodes. And again, those are stateless. That's a really fast, efficient operation. So you can add those on demand. Gets a little bit trickier when you want to add data capacity. So what we've done here is you could add more forests to the existing D nodes, but then you need to be able to make sure that you've got capacity to handle those additional query constraints. Or you can add additional D nodes. So again, we're building out our cluster gradually. And what we've got is a background rebalancer. So as you add new empty partitions, the rebalancer, based on the policy that you set in configuration, will put each of those documents and the triples into the right space, into the right place, so that you can ensure you don't have hotspots. So the next is the slightly more interesting one. And this is to ensure high availability. So within a MarkLogic cluster, you've got many nodes. And what you can do is you can replicate those data partitions across other zones. So in this case, these zones might be a rack in your data center, or it might be literally an availability zone in Amazon. So with MarkLogic, you can have that replicated. So you've got this elasticity as well as this high availability. And all of these operations are online. So you're never going to have any downtime when you're orchestrating this. And we've also got automatic failover. So that means when a node goes down or when the storage fails, another partition, another data node will take over from the data nodes that are being replicated. So again, availability and elasticity are a key to having that agility without having to compromise on the governance. And of course, this works on-prem, but we've also partnered up with the 3 major cloud vendors to offer this in their marketplaces. So you've got hourly pricing, as well as deployment automation. So we've got templates for setting up clusters, such as with my high availability scenario that I showed, that are automatically there in those vendors. But I'm not talking about magic that's 3 years off. All of the stuff that I've talked about is available today. But that doesn't mean that we're done, because we've got a lot of work to do. What we're going to be doing in the near future is taking these concepts that people are already building, that are already running in production, and up-leveling them. So we want not just have to be a MarkLogic expert in order to tap into these benefits. We want to be able to have data architects be able to work at the language of their business, be able to describe the policies in the languages of their business, and have the smart database affect those changes automatically. So that's the direction we're going. But all of the stuff that I talked about today is available now. OK, we're nearing the end here. So I want to summarize here. So we've talked a lot about busting silos. So the problems with silos in organizations, not having a 360-degree view of your data, your core assets in your business, as well as not being able to govern that data according to your policies. Rethink the problem by starting with your API, starting with business value, and then working backwards. Again, because data integration is expensive. You want to do as little of it as possible. But you want to deliver immediate value and iterate on that. That's what API first is all about. So it's rethinking how you plan those data integration projects. Expect and embrace change. Change is inevitable. It will always happen. You want to use that as a benefit, not as a way to introduce risks. You want to take advantage of the flexible data modeling, the way to link things up differently in MarkLogic, and use that as an advantage. Govern by default is about ensuring that all access to your data is according to your policies. And as such, that needs to be enforced at the data layer, and it can't be entrusted to an application. And finally, deploy anywhere. Deploy anywhere gives you the flexibility to deploy on-prem or in the cloud or a mix of both, and to scale up, scale down without having to compromise on the availability in your system. So with that, we have plenty of time left for questions. So please, I think we've got a mic out there.
Yes. Is it on?
Does anybody have any questions?
Just raise your hand and I'll pass the mic down to you. And Justin, if you won't mind, if someone does ask a question, just repeat it.
Will do.
Thank you.
Oh, I will actually land on this slide. So these are, I did about 50% here. I think I hit about 50% of this. But these are the most relevant technical sessions. Of course, there are lots of customer sessions that you should definitely attend as well. But we'll be recording these, and they'll be made available asynchronously after the event.
So any questions, raise your hands.
Don't be bashful, or is everyone just really hungry?
No? Going once?
Yeah,
Oh,
a couple
here we
right
go.
there.
Let me pass this.
So you walk through the example of the graph model with tuples, with triples, and the traditional data model that we use with MarkLogic is not unstructured data and XML or JSON, which is the tree model, right? Do you have any good examples of how you query across the two models?
Querying across the, yeah, so let me go bring back the. Yeah, so we have query languages built into the database that are tuned specifically for those models. And they're designed to work together. So for example, if I want to do the inference of my purchased over the graph of customer, order, and product, that's even a dedicated triple store does not do inferencing very efficiently. That's a lot of joins. So what you do is you limit that inferencing over those triples to just the universe of customers that you're interested in. So the first thing you do is you'll search over those documents and use that, pipe that into your inferencing query. So I can search along the attributes of the customers and their related orders and then pipe that into my inference. The same thing with really any of these. So I could use document search to find the universe of things that I'm interested in, and then use something like Sparkle to query over the triples to find out relationships, to do those graph-style queries. You can do that in a single request, not necessarily in a single query. So things like the new optic language in MarkLogic 10 are the direction we're going with that. So you can do a lot of those integrated style queries in the same language. But even if it's not in the same language, it's still in the same request. So that means it's operating in the same transaction, for example. So you'll always see a consistent view of the data regardless of how you're querying it.
Anyone else? Oh.
Hi. We have typical architecture today where we have front-end silo systems built on RDMS, and we bring in data to data warehouse, which further goes down to marts and which is used by business intelligence. Now with API first design approach, we can actually probably replace the middle layer. However, the front-end RDBMS systems and the back-end marts and BI, data warehouse marts and BIs are still going to be in a traditional RDBMS or relational world, right?
Absolutely.
How do we solve the puzzle of API first, early time to market? And the reason we bring the data even before we realize value out of it is because it's bringing the data when we need it is a lot time consuming compared to bringing data earlier beforehand, right? That's the only reason we bring data into data warehouse. Even if I bring MarkLogic, how do I solve the puzzle of front-end RDBMS systems and the back-end marts and BIs?
It's a very good question, and something we work very closely with our customers on. So the idea with MarkLogic is not to have a big bang swap out all of your systems of record and your warehousing environment. That's not what we're advocating. We're advocating MarkLogic as the hub in the middle to make those systems better. So have your in a bank, have your traders working on their trading systems. That's probably not a job for MarkLogic. That's already a solved problem. But if I want to get a risk profile across all of the trading systems, that's what you do in the hub. Doing observe the business versus, as opposed to run the business, doing observe the business. That's a great job for your data warehouse. But that data warehouse needs to look at data over all 160 of those trading systems. That's a job for the hub. So the hub can make your data warehouse or your data science environment better by providing precise slices of governed data. And then in some cases we've seen where somebody's pushing all of their data into the data hub, and they say, well, why do we need this source system? So we've seen people roll down their mainframes, for example. So I'm putting all my mainframe data in the hub anyway, and I'm issuing queries on that. So maybe I can now start thinking about planning to retire my mainframe. But that's not typically where we start. We want to have the hub as kind of the fulcrum in the middle that makes both ends of that scenario better. Does that make sense?
We've got one question back here first.
This is about data lifecycle.
Yes.
A client that has a need about 7 to 10 years worth of data we need to keep online. And in Data Hub, when we keep this history on a low-cost storage, how does the performance affect when you keep all these volumes of data on a different tiered storage, and at the same time we need to provide this performance?
Yeah, so the question is about the trade-offs between performance and cost. And it's really what kind of performance and what kind of cost you want. The flexibility of our tiered storage model allows you to operate anywhere along that spectrum. So you could have, so one scenario at the extreme end of that spectrum is you could index your database, those partitions, those forests, and then store them on something like HDFS or S3, and not even have them connected to a MarkLogic database. And if a regulator comes back and says, I want to see something 7 years old, you say, in S3 I've already got this pre-indexed data. I can now move that to a place where then I can attach it to a live MarkLogic instance and make it queryable. So there's really a lot of flexibility by having the ability to move around and put those data partitions on the place that makes sense in terms of your SLAs and cost trade-offs.
think there was another question up here.
Yeah, the
Here.
data hub concept. Oh, sorry.
Thank you.
Make sure. Can you guys hear me? Yeah, on the concept of your data hub definition. So there are a couple of things come to mind. Are you looking this as a master and slave layer? So master of query exchange and drive business logic out of it, yet slave of the sources that it's actually querying the data from. So the question is, do you need to actually load the data, or can you actually do an abstraction layer of a business logic to multiple sources versus load everything into MarkLogic and do that?
That's a great question. So MarkLogic is often not the system of record. So in that banking example, the trading system is the system of record for those trades, whereas MarkLogic is the system of record for risk calculation. That's the integration of all those trading systems in order to calculate systemic risk across the bank. So the system of record is in the eye of the beholder. But in order to get the advantages of MarkLogic's indexes and the ability to track provenance and history, you need to load the data in MarkLogic. So MarkLogic is not going to do anything for you in as the hub for a federated environment. In order to take advantage of MarkLogic's indexes, its security model, you need to load the data into MarkLogic. It may not be the data, it may be the metadata. So here is the metadata about the trades that I executed, and I want to be able to then have a pointer back to the trade instance. Or maybe that's documents, or maybe that's profiles of bad guys. But in order to take advantage of MarkLogic's unique differentiators, you have to load the data in there in order to index it.
Any other questions? Hands up? No? Going
Let's eat.
once?
Thank you,
Thank you,
everybody. I'll be around.
Justin, and thank you, everyone, for attending.